Hi, welcome to this Open Security Summit session in June 2021. And this Stephen is going to cover, which I think is a really important topic, especially for my world where we're trying to scale, which is around infrastructure as codes. So over to you, Stephen.
All right. Thanks, Dennis. This is great. I've got a prologue up here. I'm starting it like a film. Because typically when it starts, you get some kind of scene gets set to kind of draw you in. I wish we could have done this video and used it in the advertisement. But here's the scenario, right? An alert comes onto your Slack, and if you're not familiar with Bridge Crew, we have a platform that plugs into, say, your cloud at runtime, and will tell you if you've got misconfigurations and create workflow around that. So something comes in and says, hey, you should make sure your all data stored in AVS is securely encrypted. You have a violation of your security policy. All right, so now you have step two. What do I do next? Well, this is kind of where the problem lies. Then you might, all right, maybe you're really smart and connected and you've got pager duty. And so now Jane, the SRE, has a pager message that there's a misconfiguration on EBS volume. And if you're wondering, by the way, this is standard issue Bridge Crew. I've got one right here just in case things go off. And the next stays. All right, so now Jane asks Barak, who created this volume. Barak goes to the cloud trail and he says, cloud trail? All right, well, let me just check the cloud trail here. Looks like everything got created by Terraform. Terraform is the account that actually our Jenkins or GitHub Action, our CID uses to deploy all of our Terraform on our infrastructure as code. Okay, so we didn't learn anything from that. That wasn't very good. So now we start asking, that's not a good question. Did anybody trigger a release on Friday? All right, great. So he asks Guy doesn't know. He starts talking about the size of the organization. We're stuck, right? So you do what everybody else does. You create a Jira message, Jira ticket, and you say this, and now it's like, now you pay past the Jira. And what can happen that is worse is that, all right, this is not going to happen overnight. It's important. So you, instead of changing it at source declaratively, you go into the AWS console, you start fiddling away, and you bring the resource back into compliance manually. Great, at least you're safe for now. Or are you? Because if your DevOps team perhaps is monitoring drift, they see that now the cloud is different from the infrastructure as code definition. And so they push it back. Of course, what happens then? Well, now you're back to here and here and here and here. And now we're in this kind of circle of Jira reassignment and trying to figure out who did what. And the mean time to remediation goes through the roof, right? Okay, so that's me setting the scene, just one scene, but it's a very important one. So this is what we're going towards, is DevSecOps strategy with a new release of an open source project we have at Bridge Crew called Yor. And I don't know, you have to be a supreme Star Trek geek to understand that is a Star Trek character. It's also a weird 80s film, but there is a Star Trek character called Yor at the moment. And it's the automation of infrastructure as code tagging and as such tracing. So you think of it like luggage, well-tagged luggage or your phone. If something happens to it, you can trace it back to where it is. That's the idea here. My name, I haven't introduced myself yet. Steve Giguere. I am a developer advocate at Bridge Crew. This is all the ways to get a hold of me if you want. I have Twitter with underscores either side of my name, which is super hard to read there. Find me on LinkedIn. My name's really unique, so it's actually annoyingly easy to find me, but easy to find me. I have a Twitch show at 5 p.m. on Fridays where I just talk about cloud native security. Check it out there. I have a podcast, and that's some of the companies that I drifted through over the past 7-8 years, exploring different elements of security, now landing on infrastructure as code specifically. And if you like beer, by the way, I have a YouTube channel. So I'm taking a big step back, but I'm going to blow through this. So the 5 ideals of DevOps, as we know, which was created by Captain Kirk, we're focusing on what is a good working environment for DevOps, but actually it translates directly to open source, right? So we can think about locality and simplicity, focus, flow, and joy, improvement of daily work, psychological safety, and customer focus, and that's all great. Now, obviously this was created by Gene Kim, but he's kind of like the Captain Kirk of the world, right? He's telling people what to do. And unfortunately, security teams are all lining up going, all right, how do we talk to these DevOps people? I guess we'll do that thing that they said and try and work out what that is. Let's buy some tools. Buy some tools? Yeah, let's buy some tools. And then let's give them to the team and send them down to the planet. Which I think in security, we all kind of know that it kind of sometimes doesn't work. Adoption is some trouble. Some people obviously get killed in the process. Guy can't get his phaser off stun. It can be a problem. So if we think of the Scotty version of this, and let's go with the young Scotty version of it, it's a little bit different. Now we can look at what they mean in terms of security, and these definitions in terms of security, I actually totally stole from another guy who's Glenn Wilson. He wrote, I don't want to call it a companion, but I look at it kind of like a companion to the DevOps handbook called DevSecOps, a leader's guide, and he kind of translates it. But again, it lacks the practicality that a practitioner like myself needs. And so if I were to translate this, I see open source as something I can run and control, check. It integrates into my workflow, check. Provides actionable education and feedback, amazing if it does that. Encourages collaboration and makes the product better and safer. These are all good things. Plus, no cost, self-service, scalable, all awesome, right? The only big problem is finding out what are the good ones you have to use, and this is why you're participating in all of these wonderful talks, because open source are like triples. They're multiplying at a ridiculous rate. And when you talk about security, I mean, actually, at the top of this, it says, are you overwhelmed with open source? Yes, you are. And if you look at security, although it's a subset, it's still complicated, right? So I'm going to show you both our new open source project, how this fits into your workflow. I think of a workflow in terms of like a layer cake, in terms of like you've got our buttery biscuit cloud base, and then you start working up to the application, the dependencies, then you containerize it, send it off into an orchestration, hope you did all that right, define declarative deployments, put it into runtime, and all that work you did on the way, you still have to watch it and hope for the best. So I've added an extra layer at the bottom there called traceability. Now I used to only have 7 layers to my cake, and now I have 8. And that's quite good, because that implies that should all of my early shift left work not be perfect, and whenever is it perfect, I can translate runtime events back. And that's what we're going to talk about. And then ways we can leverage that in different use cases. What I'm going to be talking specifically is mainly Yor, even though Chekhov's listed there twice. It's only there twice because it has a factor in 2 parts of the layer. But I'm going to start with Yor because that's new and it's exciting. Now, you should worth knowing, Yor only came out a month ago, not even, just barely a month ago. I think it's on 0.1.62, but it's open source. So open source always tends to have 0. Whatever, right? But the idea behind it is that it is a tagging framework for infrastructure as code. Framework sounds a little bit more glorious than it is, but it's a way of providing consistent strategic tagging when you're creating, for example, Terraform, CloudFormation, ARM templates, and soon to be YAML and Kubernetes.
Sorry, Stephen, can I ask you a question? So
Yeah,
when you mean tagging, you mean actually tagging the pull requests, the commits, the issues, or the code itself?
I mean tagging the Terraform code. I'm using Terraform as an example here. I mean tagging the Terraform itself.
The actual code itself, adding tags to the code.
You got it. So you'll see what I mean. I'll show you exactly. I'll do a demo.
Cool. Yeah, but this is great because we have this problem right now, right? Like we have we have a Kubernetes cloud deployment where we have multiple repos, multiple versions, and synchronizing those things, it's not trivial, right? So that's why the more automation you can add, this sounds really, really interesting.
All right, awesome. So that's the idea. Now we're talking about built-in best practices. Yes, they exist for ownership and tagging and tracing across different languages. This actually, if I'm on camera, I don't expect anybody to read that. It's not huge, but it's big enough that I actually printed it out. Some nice bedtime reading, effective AWS resource tagging strategy. Now Azure has one too, GCP has one, Google has one. So all the different platforms have their different links that are telling you what you want to do in that space. The sort of TLDR of it is that Now in italics, I've got things that are more strategic in terms of business strategy, like employing a cross-functional team to identify tag requirements, assigning owners to define the tag value propositions. But in terms of automation, number 2 is kind of like the big one. Use tags consistently and strategically. Focus on required tags, start small. You don't have to go too crazy with tags, and we'll see that. Using automation to proactively tag, and using automation, which is what we're going to solve today, and then find a way to remediate untagged resources, which is why I've mentioned Checkov, because you can use that to find infrastructure as code that hasn't been tagged.
Yeah. So on this one, right, wouldn't one of the practice to actually do it first quasi manually, just to get that one use case well, and then automate it?
You could do it manually in theory, but it becomes a bit of like, you've got to find a way to make it consistent. And then
absolutely.
The more you scale, you get a bit. Yeah, exactly.
Oh, absolutely. It doesn't scale, but I think sometimes what I've seen is that it's also sometimes easy to actually. I know you say where's the automation and do the DevOps loop here. I think sometimes just having an end-to-end flow, even if some parts of it are manual, are insanely important, because sometimes you actually end up having your first bite of the cherry can actually be massive, right? And then you don't get that immediate feedback of people going, wow, I see so much value of this, let's get it into our CI pipeline, right?
You got it. Cool. So the idea, from your perspective, and actually from anybody's perspective, whether you're using Yor or not, you would, the workflow would be, you'd commit, you'd have a pull request, and there would be some automation to tag. We're recommending obviously Yor, but then when you merge apply, you have something that is tagged that is giving you some sort of traceability from what your runtime looks like and what your Git looked like. Now, what we're offering is a sort of automation, but kind of a built-in strategy as well. So you don't have to start coming up with something yourselves.
Just want to go back. Is this on pull request creation? On apply? Okay. So you only add, the tags, you do it. So basically you're going to get an extra commit on your pull request. Is that correct?
Right.
Okay.
And if you look at the way we've written our GitHub actions, it's a great question. We do have the second commit built in. So you see it go commit. If the first one is good, then you see the second
commit only happens after the merge.
Right.
Cool. So to give you an idea, one of the things that we do that we this is why I'm super interested in this, is we added a way that we label every one of our releases. So we do that after the merge. So after the merge, we actually add the label with the actual release to the pull request and the issues associated with it. So then we can control as part of the release. So this is similar. Yeah, this is really cool.
Excellent. So I'm going to go through a few use cases of this and see if they resonate with you. I'm going to start with the original problem. Now there's 6 here. I'll start with operational support. So that Slack message that we had here that came in.
Yeah.
Being able to find something went wrong and get back to where we started. But then the other ideas, depending on the way we create our tags, and I'll show you that in a moment, how we can use AWS for console organization, additional automation, access control, security risk management, and then cost allocation as well. Because all of these, AWS, for example, gives us, which is what I'll use in the demo, gives us an ability to use tags, provided we've done them consistently again. So
that level, the tags are actually the labels in AWS, right? So you're actually tagging AWS resources at that level?
You got it. Totally.
Okay, got it.
Yeah.
Okay.
So I'll give you a really quick example. Like there's a really advanced example which combines advanced operational examples of this, where we could, once we knew what our tags were going to be, we could create an IAM role and policy, create a Lambda function based on that, attach it to CloudWatch events, and then use the tags to create workflow. So all that manual stuff I want to do, I could do it all without touching anything. Or I could do kind of the easy stuff. So this is where I'm going to just kind of pop over to this world over here, where I'm in my, I want to be in the log. I'm in my terminal and I'm looking at a very simple AWS S3 bucket, right? So I've not committed this yet. And I can actually, I've got Checkov in here. So I can already see that if I hover over there, I've got all sorts of bad stuff that I should fix, but I'm not going to fix just now because this isn't a Checkov demo. But I want to get this tag. So what would ideally happen is I would make all my changes, perhaps do all my Checkov fixes ideally, and then I would check this into my CI pipeline. My CI pipeline would go through the stages that we've just seen, and it would run Yor. Now, if I was going to go with the simplest possible thing and do nothing special to Yor, it would run, and these are what would be the default tags that would run. It would extract from Git the organization, the repo, the file itself, the commit ID, the modifiers, so the users who modified this resource, and certain dates. And it would add, and then it adds one which is specific to us, which is called Yor trace. And what that is that is a combination of the commit and the unique resource. So that's more granular than the commit ID itself. So that is something that we generate. Now, beyond that, you can create all sorts of things you want to do. Now, one thing I have done is I've created an environment variable called simple tag, and it says testing. So that's just on my desktop. And that is a way of just creating a desktop-based tag or an environmental variable unique tag there. So if I do this the most simple way, and I'll clear this out, I should put clear on automation. And then I run Yor just like this. All I'm going to do is say Yor tag -d, everything below all the Terraform that I can find, or actually anything that conforms to Yor that Yor recognizes. So it doesn't have to all be Terraform. So it runs a little bit. So you'll see it's printing out every tag because I haven't tagged anything. So it tagged a lot, but now we see what happened. All of these changes are now here in this particular resource. And we can see that my original tags are there. So I've got name, environment, those were previously there. I've got my testing that we saw, my simple tag, which is just from an environment variable. And then I've got my commit, the file, the last modification date, who did it. Now I haven't made any changes, so it's got the last modification date. It's got me as the organization and TerraGoat because these are my copy of the repo, and it's got my unique trace. So if that's all I did, I didn't try to do anything special beyond that, I've already got a pretty huge advantage. Because if I take a look at, for example, my AWS console, and I view the dashboard, and I want to start looking at S3 buckets, then I'm going to end up in a reasonably good scenario. And I'm doing this in real time. So this is always going to be a disaster if I try and do something for real.
So that demo you just showed is basically going to that Terraform, basically it understands Terraform, right? So basically modify the Terraform script to add the tags. And I'm assuming it's reasonably clever not to override other tags if they're already there, right?
You got it. Yeah, it's like everything else. It's kind of enough it qualifies for idempotent, but it's very smart in that you can't game it, and I can apply it locally on my desktop, and then it would go into CI/CD, and it's not going to make a mistake. That was thoroughly tested before this was released. You can imagine. So if I go into AWS config now and say this was the offending S3 bucket, for example, and I look at my tags, I can see all my tags are there, and I could then grab my Yor trace. They're doing this manually, right? Just the basics. I can come into my Yor, I can look in my repo, and I can find the moment. I can find the file and the moment and the tag. I could even search, the Yor tag is unique enough. It's totally unique. I could search GitHub. I could search all of GitHub, and I would find one response, like a Google whack. So that immediately solves that original issue where I have a problem. I can go find it. Well, AWS is telling me where the problem, or Bridge Crew, whatever we're doing. And I just find the right tag. And I have a mechanism automated in place already that uniquely identifies every resource like this. Cool. Question on that?
No, I love it. So this, and I think that's that sweet first use case, right? That you just want people to deploy it, right? Because basically what you're doing is you're adding that tagging capability to be able to trace down the releases, right? And so and just in Terraform, right, is I can see the insane value, right? Because especially if you have a complex Terraform script, this is going to synchronize every single one of those, right? Do you get is that ID per run or per resource?
Yeah, you'll notice that I didn't change Well, it's not per run. So if I ran it again, it would say, well, that's a good point, actually. Tell you what, let's just see
Well,
as I'm here.
no, what I'm saying is that if you create multiple resources, right?
Mhm.
So
Okay.
if I have a, yeah, so you got there, right? So that your, so when you got your multiple groups, is that
Mhm.
value the same? No, it's different. Okay, so that value,
Oh yeah.
you're going to get a value that is different, but I guess the commit is the same, right? If you
Right.
go up, so the if you the yeah the zero, right, the 6.8. So I guess
Yeah.
the git commit gives you the pull request, um identifier of the batch of changes,
Yeah.
right? And then the individual your gives you the actual line or block of Terraform code that does the thing, right?
You got it exactly right. So if I went here and I took the git commit, I could type,
Yeah, you were going to see all of them, right?
you got everything.
Yeah.
And what if I had goodness knows how many? That's where the Euro trace comes in to be really handy because it's unique.
Yeah. Exactly. Now this is awesome, right? Because I like the fact that you're making code changes, right? Because I think that more and more I like the idea that you want to make sure that the code is in a good place, right? And a lot of tools get too shy of actually going to modifying code and rewriting code and making code into a good state, right? But what we're doing here is exactly that, right? We're making sure that the code actually, as we submit, is actually in a good state, right? In this case, it's tagged correctly, right?
Exactly, exactly. Not necessarily in a good state. In fact, very useful if it's not in a good state.
Well, I guess the interesting. Let's see what else you can do, right? It would be good if you can enforce some things on it, right?
Well, yeah, then this is where the additional use cases come in because this is kind of a blow up of some of the tags I added with a few extra ones that I didn't add yet. So I've got the name and the environment. I've got the ones that are straight out of Git. So these ones are, I guess you'd call, they're not out of my control and I can't game them. They're always going to be there associated with the person and the organization, etc. But then I've got a few other examples here. I've got my your trace, but you see I've added level, PCI DSS, and team, and you're like, all right, well that's interesting. How do we do that? And how do we make things that are unique like that consistent? So that's kind of the next phase. So if we go back here again, and I'm going to move this up, and I'm going to show you the tag groups.yaml. And I'll roll this down so you can see. So this is an example of providing a config file. Now, based on the Git tags, I can create conditions that generate other consistent tags. So in this particular example, I'm going to create a new tag group called ownership. And within that group, I'm going to have a tag called team.
So just to be clear, so that's now a config file that we put on the repo that is going to be
Exactly.
used to determine some of those rules that we can enforce, right? Or some of the extra meta tags, metadata that we want to put in, right?
Exactly. So let me just do this. I'll put this down here. So you see the command line I have down here that I would do next would be adding a unique
Yeah,
file that would be stored in my workflow for that particular repo.
yeah, got it.
And the SRE team could say manage that. And what that means is that while I have a default called interfaces, if my Git modifiers match these team members, of which that's me and that's my colleague Nimrod, then they belong to certain platforms. So I know who they are. And in terms of access levels, is this belonging to production, operations, or development, depending on who they are? So now I can start to create additional set tags, again, out of the control, but associated with team members so that I can say, well, they have this much access level and they belong to these teams. And there's a variety of things we
So
can do with that.
on that development, where are you getting the master data from? Is it environment variables? How does where you get that? Is it a match on the existing tag?
Right. So if you imagine it's all a hierarchy. So the first thing that happens is my default tags are applied. So
Yeah,
these happen. Then it looks at the config file in order. So it will look here and say, right, well, the modifiers are applied now. The modifier in this case is Nimrod. So in this case, my tag groups, my platform is going to be the ownership name is going to be platform. And my access is going to be operations. And if we look back at the check-in, that is in fact going to be the case back here. When we look at our console, we can see that the team is platform. And if I can find the other one where level is production. So we can see who is involved based on that logic.
Just for me again, okay, but this runs in the CI pipeline, this thing here, right?
Yeah. Mm-hmm.
So where is he getting that information? From an existing tag or from the type of commit? So is that the user?
So the modifiers are part of Git. So
yeah,
and that's where these were just pulled straight out of Git. But once the modifiers are there, the only conditionals I have are based on modifiers. So if I match a Git modifier, which is Eurogig, then I will set a new tag, which is going to be set to my logic here, which is going to be SecEng in this case, or it'll be platform.
Okay, and then how do you determine the difference between development and production? Oh, because I'll go down because of the names in there.
The names. Yeah.
Got it. So if you're saying that, so if Matt J does the commit, the pull request is going to be mapped as development, but if Nofar or Milkana does the request, then
it's
cool.
Operations.
That is really cool.
Cool.
Well, actually, in this case, actually, that's even the Git org, just to double check. So it's not even the user. This is actually which organization you went into, right?
So in this one, I did the person, and this I did the organization.
Person. Yeah. Which is actually really cool because you can control your deployment. Right. Yeah, very cool. I'm assuming you can probably you can do branches and you can do all sorts of other things, right?
So anything that was here, because these are the ones that have already been applied.
Yeah.
So these are the ones that come in by default, and then from there I can start to build, and that's what I have to start. And there's other things we can do. We had to have filters. For example, I can say, if it happened to be in this directory, then I don't care. Just mark it as PCIDSS equals true, because that's where my data lives, for example. So I can start looking for. I can call that more security sensitive. So you can start to add additional pieces of here that provide different tags and different conditions based on the Git tags, or perhaps the physical geography of where if you follow Terraform practice, you probably should have your S3 buckets in a data directory, kind of thing that allows you to easily identify it.
Yeah. No, that can make a massive difference. I can see.
So that's pretty cool. So from there, once we see that is possible, but this was only added last week. So the fact that you're giving me feedback on it is like, this is the process I did over the last 24 hours to try and learn it myself. So now we have different elements where if we start looking at an IAM policy, I can create things like, okay, so if the resource has been tagged with this modifier or this team or this org or this any tag we created using that config file, I can limit its capabilities to stop and start EC2 instances, because the tags now provide instant ownership and instant team association. So that's just one example of what we could do with access control. There's a whole bunch of other interesting ones we're trying to hash out in our minds here. Another example.
Just go back to the access control.
Yeah, sure.
So, okay, so you actually then, where does this go? So this is a policy. So you're actually going to create a policy based on the tag?
So I'm going to create an IAM policy, which is associated to a resource. And if that resource got this tag, then its capability to do things, if it has this associated IAM policy, will be limited now, because the condition is basically a visible resource tag. So you could have done this in the past, just by putting your own manual tags or conditions in there. All I'm pointing out now is that the way we're able to create conditions on tags means this opens up more options here.
Oh, absolutely. But just sometimes my head around it. So you're actually going to add to Terraform this IAM policy.
So interesting. Yes, you could, alongside of everything is this Terraform. You can create things like this as well. You could do it imperatively, of course, but you could do this as code as well. So everything ties together.
Yeah, that's what I'm saying. But in your example, how does this get applied to AWS?
Oh, well, this can be manually. This is I'm not solving it on the fly. It could be if you could do IAM policies as Terraform. I did it manually, which is probably not the best demo, but
No, but I think what could be spectacular is you're saying, if you're telling me that, you're going to add, or you're going to make sure that certain policies, right, on that commit are now defined based on a particular tag, right?
you can do that. That's the idea.
Yeah, I think the only thing you want to make sure is that you don't have repeatable policies, right? So that's going to give a bit more challenge to to make sure that, I think you probably need an ID here for your policy, right? To make sure that's the one that
Oh,
you
I
control.
totally expected to poke holes in this policy.
No, but I'm saying that if you have an ID on a policy, because you can have policy IDs, which you're not using, but you can,
Right.
then that can be the one that you override, right?
Yeah.
And in fact, I probably would even say that in that case, you might even want to create a separate Terraform file that contains all your modifications. So you can, again, it's easy to audit. It's easy to even version control. You know what I mean? So you can say, I have a Terraform script, right? I have a Terraform script, and that has the tags, but then I have another one that I run afterwards that contains all my modifiers, right?
Yeah, that sounds cool.
Which is basically allows to say, you can have more permissive even development, you can have more restricted using production, right? And that's where, again, you go into that known good state. So we can say that, as long as the tagging is correct, which can always be verified independently, right? We now know that based on these tags, you're going to get these permissions applied to it, whether you like it or not, right?
You got it.
Or whether you forgot about it or not, right?
Yeah, exactly.
No, that is cool. Really cool. Yeah, I like that.
So awesome. I'll jump ahead, and I was going to say, I'm sure you'll stop me when you get to these. So this is one that we were playing with recently, was where we were using, if you're not familiar with Cloud Mapper, Cloud Mapper provides visualizations of your cloud environment and your connections and resources, but it also takes tags into account. So if I want to see all the PCI sensitive ones, like that one I just created, where do all my PCI sensitive S3 buckets connect? I can create visualizations based on tags, which I've designed in advance. And then seeing some of these use cases is how we reverse engineer back. Okay, so now how do I want to create my config file for these tags? So what I'm trying to do now is like sow the seeds of your imagination as to, all right, okay, this is just one thing that we could do. Additional ideas is cost allocation and console organization. So if you're looking to see how much money did I spend on this, that, for this team, for this person, for this organization, tags can be used as well in this space. And the only thing that really prevented you from using tags before was just having a consistent strategy around it to be able to visualize cost allocation, which is another way of doing things.
Well, we have this thing where if you don't tag a certain, if you don't apply a certain amount of tags, we actually close down the instance, right? Which makes sure that everybody tags to a certain degree. But the problem was we didn't have this level of granularity, because then you end up having a bunch of default tags that everybody used, which is the one, we had a tag say delete equals no, and then of course everybody adds that to their image. So, but I think it was really cool to actually apply this level of granularity, right? That I think is pretty cool.
Yeah, I thought I was very impressed when I first saw it, just with what the default tags were. And now that we've added the config file, my imagination has been sparked to create, because this is the first time I presented all these different use cases and how I thought we could use them. So it's new enough. Yeah,
and this is a big one, right? Like, I think if you go to an organization, like, they don't control, right, their what's it called? They don't control their costing, right? Very, very few can do that properly. And the biggest problem is tagging, literally. Because you and then you can do draconian stuff, but again, you'll go back to, because things tends to break as soon as you shut down a bunch of stuff, right? It becomes very hard to distinguish, right? I'll give you an example. Like, we did this thing where we cleaned up a whole bunch of AMIs, because actually it cost a lot of money because of the automation. We had like 1,000, AMIs, right? And, which is quite a little bit, right? But the problem is that we didn't have the distinction between, for example, some of the ones we use in production, some of the ones that got released, right? Because we now build AMIs for breakfast, right? Every merge to a particular branch gets a new AMI, right? So this would have made a massive difference. No, I really, really like this. And I think costing is definitely one of those where, anybody who's done AWS in this case has that pain point.
Excellent. Okay, so I'm going to just quickly tap into where Checkov comes into this. And if you're not familiar with Checkov, Checkov is a checker for infrastructure as code, looking for obvious misconfigurations. And very quickly, I think I sort of showed it because you can integrate it with VS Code so that it's just here all the time, running and showing you what's wrong and allow you to make minor changes. And of course, the alternative, if I back that up, is to just run it on the command line and just have it check your AWS and show you everything that's wrong. Or you can have it misconfigured and it does that. But the idea behind Checkov is that it can check, currently can check YAML, Terraform, CloudFormation, ARM, and what's good about it is you can combine these two now. So you can create custom rules in Checkov to look for, and you can do it in a variety of ways. Checkov is written in Python, but we recently, as of version 2 release, which I think is a couple months old, you can create YAML that looks a lot like the configuration file we just saw. And based on that, you can start to create rules that you're checking for. And the example I've got here, now, albeit this is a Python one that we wrote because it's a little bit complex, that you can plug in. But this is an idea of preventing non-security members from editing CloudTrail configurations by checking to see that certain team members are, and based on certain tags, on certain Git modifiers that are already present. And because those tags we know are consistently going to be added, now we can do our tagging and then we can run and Checkov to make sure that we haven't allowed certain people access to certain resources via our Terraform. So in a way, we're kind of almost doing these pre-flight permission checks based on consistent tagging, but we're doing it in our CI/CD. We're not waiting until we try to deploy and something permissions aren't set correctly.
So the target audience of this is Terraform, CloudFormation scripts, well, Kubernetes, I'm saying Helm charts, right? For it, right?
Yor doesn't tag Helm and YAML yet. That's, I think
I'm saying Checkov, right? Checkov does that.
Checkov does everything. Yeah, Checkov does everything.
But okay, so you're saying Yor does Terraform at the moment.
Yor only does Terraform and CloudFormation, I believe, at the moment.
Cool. But Checkov is also open source, right?
Checkov is all open source, yeah.
Yeah, cool.
Oh yeah, definitely join up and create pull requests and issues. Please do.
Yeah. So, and then so you run this where? You run this on a developer environment, or you run this on the CI pipeline?
Checkov would be part of the CI pipeline as well, although it's far more developer oriented, because if I'm working on Terraform, I just have Checkov running, checking it all the time. And as I have it, I mean, for this, we have the VS Code plugin for Checkov that just sits there and syntax highlights what you've done wrong to allow you to fix things as we go. So do you have
an integration with? So I keep asking lots of questions, but this is really
exciting. No, it's good.
Do you have an integration with GitHub, the pull request, so it shows on the UI whenever there's a problem?
Ooh. Yeah,
because a lot of our stuff now, we actually use GitHub Actions, right? As a lot of those checks, right? A lot of those checks that you have in GitHub Actions, that's one of our quality gates, right? So my question is, where would I run this to break a build, right? Because that's kind of fundamentally what you also want.
Yeah, well, you would run this in your CI and it would break a build, because you could, if you have a breach of policies. Now, there's a whole video we're about to do on what Checkov does to make sure that it's only checking for the things you care about. But
okay, but what do you mean by running on your CI? Is basically something that once I have the code checked out, I just run that. I run a command line to run that check, right?
You could do it here, or you could do the example I've got here, where I'm just looking at everything that's wrong with this one, and if I wanted to, I could add a fix, and now I have my Terraform changed in my VS Code before I even check it in. So this is a total pre-check. You can do it as a pre-commit hook if you want, so that you don't even let people check it in if it's missing certain things, or you can run Checkov as an after the fact based on some of the tagging. So there's various stages where you can run it.
Yeah, but that's what I'm thinking. Like if I run it after the fact, right, just as a quality gate, I can just do it as a Git. Well, I can just trigger from a Git action, right?
Right.
Fundamentally, that's it, right? and then that
Yep.
breaks. Yeah, I think it'd be good if you guys can add a native one, because then you can actually show some of the stats, right? Some of the a bit of like how many things got broken, even maybe a bit of a better, cleaner output, right? And that shows straight away into that pull request environment.
Cool. Yeah, it would be good. I'm gonna find out we already have that, and I just didn't know.
Yep, cool. So this is a rule. Where does this rule go? So this is a Python rule, right? Where does it go?
This is a Python rule. You can add it on the command line and say, run all the normal tools. And by the way, we wrote our own. It looks like this. Go get it and incorporate it. So we allow Python hooks, so you can just hook right in. And then we introduced, I think a much easier way is the YAML method that allows you to say, this is the name of my new check, and this is what we're looking for. These are the conditions. And this is what allows you to do things that are far more advanced, that allows you to take resources and say, this resource can exist, but only if it's connected to this, and it has this encryption, and it has this, and it's tagged with this. So you can start to use the YAML rules, like we did the conditional YAML config, to start to create quite complicated security rules with Checkov.
Yeah,
this is quite new.
Is there a database of those rules already published, or is that the way it comes out of the box?
Everything, all of these are in our GitHub repos. So all the existing ones are just there, and you can start with them and start creating other ones. And plus, if you're, there is like a visual creator in like the Bridge Crew platform. That's a free thing. You can just log in and you can start to create rules visually. So you can just say this plus this, and it makes it a lot easier than trying to figure it out manually.
Yeah, very cool.
Yeah, it's neat. So this is the idea. I mean, I'm just going to summarize quick. The idea is we build it, you secure it, you fix it, you run it, and now you have the capability to create this workflow, and you can automate everything without having to peek and poke around with ownership and Jira tickets. So that's it. You got me ready. You escorted me nicely to the end. Takeaways, tag everything. These are websites where you can find out more about these projects.
So I think what would be really cool for us to do on the next session, right, is actually a hands-on, right? Like, so we can basically do a follow-up next month or the month after, right? When you got some time. I think it would be really cool to pick a couple of scenarios, right? And then say what we want to do in this session, right, is actually do this, right? Tag this, tag that. Almost have a little bit of a prerequisite that, you have to have an AWS environment to deploy. You have to have that, but I guess, any dev that does development will have that, right? So I can actually go to my team and say, hey, can you guys pop in here, right? And learn how to tag it. Because I think that this is really cool. I think it would be good if you could come up with like a couple, maybe 3 or 4 scenarios to say like what we want to do is exactly that. And maybe if you provide, that initial, almost like GitHub repo with maybe scenario 1, scenario 2, scenario 3, scenario 4, right? Which basically gives you the, what's it called? The, like almost like the workflow that I want to follow, with the base Terraform scripts, and then maybe have some secure ones, insecure ones, and then you can basically go, right, now let's deploy this, and then let's start to fix it, right? Or let's identify, those things. I think that would be really, really useful.
Yeah, it'd be awesome. We, my colleague Matt did a session yesterday at AWS Dev Day, and it was hands-on, but it only had a little bit of the Yor bit in there because it's only a few weeks old. So we're working on integrating it into exactly what you're talking about. So then we can come back probably in a month or whatever, and we can do that.
I think Yor is really, really powerful because it addresses a problem that today doesn't have a good solution, which is auto tagging. Yeah. Right. I think that is a great gotcha, and I think that. And then tying that to trying to come up with rules based on the tags, I think that's a really good follow-up, right? But the ability to auto tag, look, I tell you, that's a problem that we have right now, right? We're trying to, and we expanded it. So the thing that maybe you want to look at, and actually we open source our one, so I'll find the link to share with you. But we adding labels to the GitHub issues is also really powerful. Almost extending the tabs, not to AWS, but if you already are in GitHub, think of the labels as a tag, because that is very powerful, right? Even in terms of, for example, failing. So we use tags a lot now, even for management, and even the stages, right, of where you are in the thing, where we go need pull request, needs this, needs fix, merge conflicts. So when you see a lot of the pull requests, the team can basically know, oh, I need to address this, I need to address that. So I really like also the idea that you start to label things. You have to start labels based on even the results of that configuration, right? So I want to say, for every commit that I have, apply this label, right? And that tells me that I reach a certain degree of maturity or a certain degree of capabilities.
Totally. And actually, if anybody else listening as well, if you want to have a one-to-one with our CTO Barak, it was his brainchild because it was his problem like yours that came up with it. He's looking for people to speak to guide its direction right now because it's so new. It can go anywhere you want it to go.
Oh yeah, I'll sign up, man. Like let's do a couple of sessions with my team, get him involved, because I would love to show him to I have a team of DevOps engineers, right? And they can totally adopt this very quickly, right? So let's do a session, right? Actually, look, let's do this. Like, why don't you bring him next month? Let's do a session with him next month. So basically, we can maybe we can do 2 sessions, one hands-on and maybe one with him, just to do a brainstorm and that conversation, and he can show some more of the vision, but also we can talk more, and maybe we can have a bit of a panel, right, on the next level of this.
Perfect. Let's do it,
because I think this is really cool. All right, man. Look, thanks for doing this session. And actually, there's a number of people who joined in halfway through. I highly recommend you to go back and see the introduction of this. This is a really cool tool and really cool technology. So good stuff. Let me stop the recording.